Alright, so today we're going to look at the circuit components. So what are the main features of a circuit and how to draw one. Now we need to note that we're now talking about current electricity. This is electricity or electrons moving around a circuit. Static electricity is a buildup of excess of electrons in an object and not what we're talking about. So what are the components of a circuit? Well, first off, for electrons to flow around a circuit and to become current, or current energy, current electricity, the circuit must be unbroken. So first off, we need an energy source. Now, energy needs to be fed into the circuit. We know this because the law of conservation of energy is really important, so it has to be true. We need to have a source of energy in there. Now, there are all sorts. There are batteries, there is mains power, that's the power in the wall, there are transformers, there's solar power, wind power, blah, 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 and so forth. There are lots of ways we can put power into a circuit. It needs a conductive path. What this means is it needs a path, an unbroken path, for the energy, or electrons, or current, to flow through. It needs to be unbroken. If it's unbroken, the circuit is not complete. And this is essentially our wires and switches. And wires are always complete, but sometimes your switches can be open or closed. Now, we also have to have a load in there. Basically, a load is anything which uses the energy. It takes the energy from the electricity and it converts it into a different type of energy. It transforms it into another type of energy that is useful. So, for an example, light bulbs, resistors, and basically anything using electricity to do something will do. Now, you're going to want to be able to draw a circuit. I suggest you tabulate this information. It would be much better presented in a table. So we're going to show you here how to draw the different symbols that are fairly standard across the globe, actually, for the various components. First off, we have cell or transformers. So a cell is one stored source of chemical energy, or a transformer is something which takes the mains power and steps it down to like 8 volts, something like that. And it's drawn like this. This is the symbol we use to represent that. This is an energy source. You have a battery. Now, a battery is actually multiple cells put together. So it's multiple sources of chemical energy stored together, usually in series, in a line. And that is also an energy source. We're going to color code our diagrams with the last side. By the way, if I was tabulating this, I would have component, and I would then have diagram, followed by type. And that's where your energy source would go. If you were tabulating it, that's what I would do. Then we have wires or leads. These are generally just a straight line. These will always be done with rulers. On here you'll see it's not because we're doing it with the pen. That's with this guy. And this is a conductive path. So it's just your wires or leads. Then you have switches. Now, this is also part of your conductive path. You can have switches closed, down here, or switches open. Now, if your switch is closed, electricity will be able to flow through it, so that's it turned on. If your switch is open or turned off, there'll be no electricity flowing through. Bulbs. Now, bulbs are load. Bulbs are you doing something with the electricity. In this case, converting it to light energy. Now, here are 3 different types of bulbs. They do vary a bit. And it depends on who you're drawing them for. Some will prefer this one, some will prefer this one. This is the most standard international one, however. Anytime you look up a circuit diagram, that is most likely to be the one you'll find, and that's because it's probably the easiest to draw. You have a resistor. A resistor is also a load. A resistor can be put in there to use energy. If you've got a kettle, a jug at home, that jug, it's using the element in that jug, or the element on an electric stove, that is a resistor. You also have a variable resistor. Any knobs which you're dialing, so your volume knob on a stereo or your TV. They don't have those anymore. Volume knobs on a stereo, they still exist. That is a variable resistor, so it changes how much energy is actually able to travel through. We have a voltmeter. A voltmeter measures voltage. It's really important in working how much energy is being used up by a certain piece of gear. And we have an ammeter. It measures current, so it measures how much of the energy is traveling through. So this measures how much is being used and how much is actually traveling through. Now, we've got two circuits here drawn. There are circuits are drawn with rulers, giving you straight line rectangular diagrams. Here we have a transformer, goes around to an open switch with a light bulb, voltmeter, and an ammeter. Now switch A is open, and that means the bulb is off. And over here we see that switch B, the bulb is closed, sorry, the switch is closed, which means the bulb is on. And that's how we draw a circuit. Alright, if you have any questions, put them in the comments below. We'll get to them as soon as we can. And thank you for watching, and we'll see you next time.